My name is Dr. Manisha Gupta and I am assistant professor in Noida Institute of Engineering and Technology in MBA department in Greater Noida, and I welcome you all in the business research method class. And in today's session we are going to again discuss about the concept of the hypothesis testing, and in this we are going to discuss the two tests over here in today's session. First is your Z test and other one is your ANOVA. Now, what is basically the Z test? Z test is a statistical test used to determine whether the two population means are the different, where the variance is known as sample size is large. We have studied the t test in the last session, and in that session also the t test is used for the comparing the mean of the two different population, and in the Z test is also we are used to whether the two population mean are different or not. But here the basic difference between your Z test and t test is that the variance are known and the sample size is large. The t test is used where your sample size is small, and the test statics is assumed to be have the normal distribution, and the parameters such as standard deviation should be known in order to accurate your Z test to be performed. Means you have to know the standard deviation in advance in this study. And the Z test is basically the statistical test to determine whether the two population mean is different and or not, and the Z test is the hypothetical test in which the Z statistics follow or it is follow the normal distribution curve. The normal distribution curve formula and the concept is we follow in the Z test, and a Z stats or the Z score is the number presenting the result from our Z test, and the Z test is closely related to the t test, but the t test is best performed where the experiment has a small size, but when there is a sample size is large, then we use Z test. And the Z test assumes the standard deviation is known, and while in the t test our standard deviation is not known. Now, why should we choose Z test? What is the reason for the choosing the t test? When we use why should we use Z test, and what is the reason behind the choosing the Z test? So, we use Z test when our sample size is greater than 30, otherwise we use t test. Then the data point should be independent from each other, means the data and the point of the data will be independent from one another, means your variable should be independent, and in other words the data point is not related or does not affect the other data point, means one set of the data does not affect the other set of data. And the next point is your data should be normally distributed, means they follow the normal. If the data is following the normal distribution curve, then we use Z test. And however, the large sample size over the 30 does not matter in this. And next point is your data should be randomly selected from the population where each item has an equal chance of being selected in the Z test, and the sample size should be equal if all is possible, means in all the set of the data your sample size should be equal. Like if you are comparing the performance of the two different batches of the student, then their strength should be same. Now, this example of the Z test and the calculation, how will you calculate the Z test? Let us say we need to determine if the girl on the average score higher than the 600 marks in the exam or not, or means their average score is more than 600 or not, and we have the information that the standard deviation of the girl score is 100, means what do you mean by the standard deviation? standard deviation is just to show or tell us about the deviation from means how much the value will be deviate from mean value. And if we know the standard deviation, and that is a prerequisite of the Z test, that the standard deviation should be known in advance. And so we collect the data of the 20 girls. Suppose there is the strength of the 100 girls, but we randomly collected the 20 girls from them and record their marks. And finally, we also set our value of the significance level at a 0.05, which shows that there is a 5% chance that our hypothesis will be wrong or rejected. And in this sample, the mean score of the girl is, means here the value of the marks of the 20 girls were there, and from this we get the mean score of the girl is 261. Then the sample size or the value or the n value is your 20. Then the population mean is given, which is a 600, and the standard deviation is your 100. And by using these information, we put the value in this formula and we get the Z score. So what is basically the formula of the Z score is x bar minus by your population means, and then theta is basically your standard deviation, and n is your total number or the total number of the observation or your sample size. So, and x bar is basically your mean of the population. So 641 is your mean of the population, you minus with the population mean and by and divided by your standard deviation, which value is 100, and standard deviation divided by square root of 20. And what is 20? 20 is the number of the observation, and you will get your Z value and P value, and you will see that we have determined our level of the significance is 0.05, and this 0.05 value, and this is our P value, and the P value is less than 0.05 value, means our hypothesis is accepted. And since the P value is less than 0.5 value, then we can reject the null hypothesis, and we conclude the based that our result that the girl's average score is higher than 600 marks. So these were your basically Z test. Then what are the basic difference between Z test and T test, and how we decide that whatever the test we use. So for this, we should perform the Z test when we have and when should we perform T test. What is the reason behind when should we perform Z test and when should we perform the T test? If the sample size is large enough, then we use Z test, and T test will be concluded with the sample size, means when there is a small sample size, then we use for the large sample size Z test, and for the small sample size T test. Then for the large sample size, sample variance will be better to estimate the population variance. So even if the population variance is unknown, then can also be used the Z test. Similarly, for the large sample, we have the higher degree of the freedom, and since the T distribution approach, the normal distribution means there is a normal distribution curve in our Z test, the difference between Z score and T score is negligible. Now suppose if you have the sample size 30 or the less than 30, then suppose you have the sample size more than 30, then you use Z test, and if you have the sample size is less than 30, then you know the population variance. If you know the population variance, then you use Z test. If you don't know the population variance, then you use T test. These steps we follow when we try to decide what type of the test we are going to use. We are going to use T test or Z test. Next is our ANOVA. So what is basically the ANOVA, or the analysis of the variance? The ANOVA test is the way to find out if the survey or experiment tested has the significant or not. Or in another word, we can say that it helps us to find or the figure out if we need to reject the null hypothesis or to accept the null hypothesis. We use ANOVA also to proving or disproving our hypothesis. Basically, you are testing the group to see if there is a difference between them. Example, like when you might want to test the different group, such as a group which is in the which are basically the psychiatric patients are trying the 3 different therapies. Suppose the example is giving on the people who has the psychiatric problem, and the patients, doctors are using the 3 different methods: counseling, medication and biofeedback, and you want to see that which therapy is better over the other. In this, what we do, we try to establish the relation between, and if we want to know that what therapy is better, we are going to use these ANOVA. And the other example is also given. Suppose the manufacturer has a 2 different process to make light bulb, and they want to know which give the better result. So, if you want to know which is giving the better result, then also you can use the hypothesis. And also we use the ANOVA table. There is one more example, like the student from the different college take the same exam, but you want to see that which college has performed better. So, ANOVA is basically to find out that you are testing to see the difference between them, means how the one group is different from the other. And there is a one way or two way, refers to the number of the independent variable. There is a one way ANOVA, two way ANOVA. So, one way, two way is basically showing the number of the independent variable in our analysis of the variance test. The one way has the one independent variable with the two level, for example, bread of the cereal. Then two way has the two independent variable, and it can have the multiple level, for example, brand of the cereals and calorie. So, brand and calories has become the two variables. In the first, there is only one variable, brand of the cereal. Then the group or the level are the different group within the same independent variable, and in the above example, our level of the brand of the cereal might be, there are the different flavors, like if we are talking about the one single brand, but in that single brand they have the multiple product with the different flavors. So, there is a few example is given, like charm, raisin, bran, cornflakes, and the lot of the 3 levels, and your levels for the calorie might be sweetness, unsweetness, and the other 2 levels. So, in the two-way ANOVA, or with the two-way ANOVA and with the replication, you have the 2 groups and the individual within the groups, and you are doing more than one thing, or the 2 group of the student from 2 different college taking the 2 tests. And if you only have the one group taking the 2 tests, you would use without replication. Now, in the ANOVA, ANOVA is basically the 2 types, one way ANOVA and the two way ANOVA, as we have seen in the previous slide also. In the one way ANOVA, the between the groups, that it means we are use and want to test the 2 groups to see if there is a difference between them or not. And in the two way ANOVA, without replicating, used when you have the one group and you are double the test that the same group. For example, you are testing the set of the individual before and after taking the medication to see it if it is work or not. In the one way ANOVA, there is a set of the 2 groups, and in the two way ANOVA, you are testing the same group in a different time interval, and the two way ANOVA with the replication. In the two way ANOVA is also, in the one we are replicating the study, and in one we are not replicating the study. So, what is happening when you replicate the 2 group and the member of those group are doing more than one thing, means the 2 group of the patient from the different hospital trying the 2 different therapies, and you want to find out the which hospital is doing well and the whatever the therapy is doing well. Now, we talk about the one-way ANOVA. The one-way ANOVA is used to compare the 2 means from the 2 independent or unrelated groups using the F distribution. So, there is a F distribution which is basically talk about the difference in mean and the distribution of the frequency. In the one-way ANOVA is basically compare the 2 mean from the 2 independent or unrelated group, and in this we use the F distribution, and the null hypothesis for the test is that the 2 means are equal. If suppose the result of the 2 groups, like in the we have taken the previous example, like the doctor giving the 3 different treatment, and suppose the result of the all 3 treatment are same, then what does it mean? That our null hypothesis is accepted. And there is one more example. For example, we use one-way ANOVA. There is one situation is given. You have the group of the individual randomly split into the smaller group and the completing the different task. For example, you might be studying the effect of the tea on the weight loss, and from the 3 group, and what is it? There is a group of one is green tea, black tea, and there is a group of the no tea. So, you just try to find out the what is the relationship between the tea and the weight again, and you divide the group when you have offered the green tea, second you have offered the black tea, and the third group you did not offer a tea. So, you can understand is there any relationship between the using of the tea and the your weight loss. And in the situation 2, what we do similar to the situation 1, but in this case the individual are split into groups based on the attribute they possess. In the first situation you randomly divide the group, but in the situation 2 what you do, you choose or divide the group on the basis of their attribute or the attribute of the population. For example, you might be studying the leg strength of the people according to the weight, and you could split the patient into the weight category, means you try to establish the relationship between the weight and the strength. So, you divide the people depending upon the weight. One category who has very obsessed, then other is overweight, and last is normal weight, and then you measure the strength according to the weight of the people. So, in the first situation you divide the group randomly, the second situation you divide the group according to the certain attribute of that sample. And what is the limitation of the one-way ANOVA? The one-way ANOVA will tell you that at least 2 groups were different from each other, but it won't tell you which group were different, and if you test returns or the significant F stats, then you will need to run again any other test to know the exactly what the group has a difference in means which group has a difference. So, in one-way ANOVA we just only establish how the one group is different from the other group, but we do not know that which group is more diverted from our population means, or the average score how much they are different from the mean of the population. Next is the two-way ANOVA. The two-way ANOVA is the extension of the one-way ANOVA. With the one-way ANOVA you have one independent variable affecting the dependent variable. In the two-way ANOVA, this is basically the extension of your one-way ANOVA, and with the one-way ANOVA you have the independent variable which is basically affecting your dependent variable, and with the two-way ANOVA there are the 2 dependents, means use the two-way ANOVA when you have one measurement variable like a quantitative variable and the 2 nominal variables, means We use the two-way ANOVA when we have one quantitative variable and two other variables, that is your nominal variables. And in other word, if your experiment has the quantitative outcome and you have the two category explanatory variables, means there is the two more category and you want to understand that the how your outcome or the quantitative outcome has happened. For example, you might want to find out there is an interaction between income and gender for the anxiety level at a job interview. Means you try to find out the interaction between your income and gender for the anxiety level at a job interview. Means income also, gender also, and you are taking the one more thing which is anxiety at a job interview, and the anxiety level is the outcome and the variables that can be measured is your gender and income. Gender and income are the two categorical variable, and these categorical variable is also your independent variables, which is called the factor in a two-way ANOVA. Means here there is a two independent variable, gender and income, on which we are trying to establish the relation with our dependent variable, which is the anxiety level at a job interview. So, there is a total 3 variables in our two-way ANOVA, and there is only 2 variable in one-way ANOVA. One is your independent variable, other one is your dependent variable. But in two-way ANOVA, there is one dependent variable and 2 independent variables. The two-way ANOVA, the factor can be split into the levels. Means the factor which we have seen is our independent variable, which is called as factors. So, when we split the factors or we split the independent variable, for example, the income level is split into the 3 level like your low, middle and higher income, and gender will be split into 3 level, male, female and your transgender. Then the treatment groups are the all possible combination of the factor, and this is the example of your means treatment group. Suppose what will the combination will become 3 into 3, there is a 9 treatment group will be established. Means the combination of here 3 groups according to the income and 3 groups which is a male, female. Talk about the 3 low income, middle income, higher income, then male, female and transgender. So, there will be the combination male with the low income group, middle income group, higher income. Same with the female with the low income group, middle income group and higher income. In the same way, transgender is also low, middle and higher. So, this way they will form the 9 treatment groups in this. And there is a certain assumptions in the two-way ANOVA. First is the population must be close to the normal distribution curve. Means the population will be have some normal distribution curves. Then the sample must be independent, and the next assumption is that the population variance must be equal. Variance in the population should be equal. And the last is the group must have equal sample size. Means all the groups which we have formed, there the 9 treatment group has formed. So, all the group has equal sample size. Next is MANOVA. MANOVA is just the ANOVA with the several dependent variable. It is similar to the many other tests in the experiment, and that is the purpose to find out if the response of the variable. Means your dependent variable is changed by manipulating in the independent variable, and the test help to answer the many research question, including do the change in the independent variable have the statistically significant effect on our dependent variable or not. This question can be answered by the MANOVA. And the other thing is that what are the interaction among the dependent variables, means how the other dependent variables interacting with each other. Then what is the interaction among the independent variable, means how the independent variables are interacting with each other. MANOVA is basically used when you have a more than one dependent variable. The example of the MANOVA is given. Suppose you want to find out the difference in the textbook affected student score in the maths and the science, means how the textbook is affect the score of your maths and science. Suppose improvement in the maths and science means that there is a two dependent variables, two dependent marks of the science and the marks of the maths, they are the two dependent variable. So, if there is a two dependent variable, then MANOVA is the appropriate method, and the MANOVA will give you the single or the univariant f value, means ANOVA will give you only the one significant f value, but MANOVA will give you the multiple f value, and the MANOVA test the multiple dependent variable by creating new or artificial and also the dependent variable that have the maximum group difference, and these new dependent variable are linearly combined with the measurement of the dependent variables. Thank you everyone, and for this session, but we will continue the ANOVA in the next session also for the practical aspects, and with this I will thank you for this session.